Hello everyone, my name is Adlet. I want to solve 4 problems on the topic of optics, so let's go. Our first task is a double slit is illuminated simultaneously with an orange light of wavelength 630 nanometers and a light of unknown wavelength. A bright fringe of m equal to 5 from the light of the unknown wavelength overlaps the fringe of m3 from the orange light. What is the wavelength of the unknown light? So let's go. We need to understand the setup. So we have a double slit experiment with two light sources. One is unknown wavelength and another one is unknown wavelength. So we need to identify given data. So wavelength of the orange light is 630 nanometers. For the orange light, the overlapping bright fringe is M3, MO3, M orange is 3. For the unknown light, the overlapping bright fringe is M5, M unknown, so M5. So we need to unknown wavelengths of unknown light. Okay, so in optics we have a formula of the fringe position formula. It's like Ym equal to m lambda d and d. It is the distance between two slits. It's first slit and second slit. So we need to write two formulas about lights. Oh, I forgot nanometers. So first one is Ym1 is m o lambda o d over d, and unknown light unknown, so m unknown lambda unknown distance and d. So Ym is equal, so we need to put them together. So m0 lambda 0 distance d equal to m unknown lambda unknown d over d. So we need to cancel them d because they are equal, and we have this formula, and we need to find this. It is a wavelength of unknown light. So lambda unknown equal to maximum of orange light and the wavelength of orange light over maximum of unknown light. So 3 times 613, okay, and over 5. So we have 190 minus 9 and over 5. It is 378 nanometers. So our task is done. So next task is number 2. Light of wavelength 550 nanometers illuminates a double slit, and the interference pattern is observed on a screen behind the slit. The third maximum is measured to be 3 cm from the central maximum. The slits are then illuminated with a light of a wavelength 440 nanometers. How far is fourth maximum from the central maximum? So we need to identify what is given. So let's write lambda first, 550 nanometers, and Ym distance from the central maximum to third maximum is 3 centimeters, and we have second light of wavelength of 440 nanometers, and maximum 4, and we need to find how far is fourth maximum from the central maximum. So we need to find Ym4. So we have the fringe position formula that was used in first task. So let's write again two formulas. D Ym equal to m lambda d distance. We are given Ym m lambda. So let's write. First, our first formula is Ym3 and 540 nanometers d distance, and the second formula is Ym4 440 nanometers and d, and we need to divide. So by division we'll get a formula. So our formula looks like this. So 3 centimeters Ym4, we need to find this. Yes, it is our formula looks like this, and we need to find this. So let's cancel what will cancel. 3, okay, and we need to do proportion like this and this, okay, 4 and 550 Ym4. So it will look like this. 4, it will be 1760, and we'll get 3.2 by calculation, 3.2 centimeters. So it's like previous task. So let's move on. I have two tasks that are related to each other. So let's go. Task number 3. Figure 33.9 shows the light intensity on a screen behind a double slit. The slit spacing is 0.2 millimeters and the wavelength of the light is 620 nanometers. What is the distance from the slit to the screen? So it is intensity and x. So we will not use the intensity. We will solve it by the formula of fringe position, ym equal to m lambda distance and the d. It is our zero maximum, and it is 1 2 first and 2 second, first and second, and here our total length is 2 centimeters. So we need to find the distance from the slit to screen. So let's go. At first we are given of distance of the slits, spacing slits, 0.2 millimeters, and the wavelength of 620 nanometers. So by using this information, we'll find the distance between slit and the screen. So we need to find ym. Ym is equal to 2 centimeters. It's our total ym. If you use first maximum, we need to divide it to 4, because here we have 4 maximas, 2 at right side and 2 and at left side. So we need to find distance of first maxima from the central maxima. It will be 2 centimeters divided by 4. It will be 0.5 centimeters. So and m maximum will be 1. So let's solve it. Distance. Oh no, let's write at first our formula ym d m lambda the distance. So we need to find this distance ym m lambda. So we have all this information. Ym equal to 0.5 centimeters, 0.2 millimeters, maximum 1, and 620 nanometers. So let's solve it by calculator. It will be 0.1. So it will be 1.6 meters. So here our answer. So let's move on. Number 4. Figure 33.9 shows the light intensity on a screen behind a double slit. The slit spacing is 0.2 millimeters and the screen is 2 meters behind the slits. What is the wavelength in nanometers of the light? Wavelength. We need to find wavelength of the light. So let's go. It is we have same information, but instead of 1.6 we have distance from the slits to screen is 2 meters. So let's go. Let's write what is given us. What is given to us. That d slit spacing is 0.2 millimeter. Distance is 2 meters. At previous task we have ym 1 is 0.5 centimeters and m equal to 1. So we need to find lambda. It's easy one. So let's go. Ym, we need to write formula of fringe position. Ym d m lambda distance. So we need to find this lambda equal to ym1 distance over m1 distance. So we have all information. So 0.5, 0.2 millimeters, and m1 equal to 1 and 2 meters. So do this calculation. So here it is our wavelength. We found our wavelength. So I think it was understandable for you, and thank you for your attention.